kite surfer must be able to assess whether conditions are safe or unsafe for their sport. There are many factors to consider, and these are introduced in this video. The quality of wind is of primary importance to a kite surfer. Clean wind has consistent speed and direction. Gusty wind has changing speed and changing direction. Clean wind is easiest and safest to learn in. Slightly gusty wind can be handled with the appropriate skills, and very gusty wind makes kitesurfing unsafe and not that fun. Generally, wind becomes cleaner when travelling over flat, smooth surfaces for a long distance. Whereas wind that travels around angular surfaces or steep slopes becomes gustier and more turbulent. The wind can also stay turbulent long after passing a significant obstacle. This can be called the turbulent zone or wind shadow. For some obstacles, the wind can become turbulent well before reaching it. One generic estimate is that the turbulent zone is 7 times the height of the obstacle on the downwind side and 3 times the height of the obstacle on the upwind side. Therefore, taller obstacles create larger turbulent zones. The reality is far more complicated and depends on a number of factors. The shape of the object is very important. Gentle slopes with a smooth surface can create negligible turbulence. An angular shape or steep slope, however, creates a far larger turbulent zone. The total number of wind obstacles is also critical. The turbulence from a lone object can disappear quickly. It has clean wind on all sides, which helps to remove turbulence. However, with numerous obstacles, the turbulence will last far longer. The wind deflections can combine together. Another key factor is the wind speed itself. When wind speeds are higher, the gusts are stronger and carry further. Ultimately, your best bet is wind that approaches over open ocean. The wind's approach is then clear of obstacles. To be sure, you should walk to the launch area and feel the wind. You should be able to feel if the wind is changing. Obstacles can also alter local wind speeds. When wind is forced into a narrower space, the airflow is forced to speed up, and wind moving into a wider space will slow down. Wind passing between 2 mountains, for example, will speed up. Or wind climbing a slope will be forced to speed up. This is why it might sometimes seem windy enough when you arrive at the top of a beach or sand dune, but when you walk to the water's edge, the wind's not so strong. In this next example, the airflow is split by a peninsula. The wind is forced into less space along the coast, and the coastal winds therefore are stronger than the wind in the open ocean, with this wind direction. Unfortunately, it's rare that kiters can take advantage of the Venturi effect, since it's almost always accompanied by increased gusts. A steep upward slope can create climbing wind, and since this airflow is being constricted, this updraft can be much stronger than local winds. This creates an area of lofting risk. You could easily get pulled up if you are not cautious. Bear in mind that for very steep objects, such as buildings or cliffs, the oncoming wind can rebound from the face. This creates high pressure and eddies. Subsequent wind is then forced to climb before it even reaches the obstacle. This means the lofting zone may be further from the obstacle than you expect. Another important wind effect is the wind gradient. This is a common phenomenon where the wind at ground level is slower than the wind higher up. Wind at the lowest levels is affected by drag from the surface. This drag can come from something as small as grass or even choppy water. Over flat water, the wind gradient will be less noticeable. It's important to understand that the pull you get from a certain wind speed is not linear. The pull you get from a kite is proportional to the air speed squared. What that means is if you double the wind, say from 15 knots to 30 knots, then you're not going to get double the pull from a kite, you're going to get 4 times the pull from your kite. And then that is just with the kite sitting still in that wind speed. When you factor in that the kite will turn quicker and shoot across the window quicker and respond to any minor steering inputs or steering mistakes, then it actually feels like the kite is several times more powerful when you double the wind speed. What this means is you have to take a very sensible approach to wind speeds. After your lessons, try to get lots of hours in a safe wind speed, say from 10 to 20 knots. Once you have some experience there, then you can start on the low 20 knots. Once you have 100 or 1,000 hours in those kind of conditions, then you're going to be prepared for 30 knots, assuming of course that you have the correct kite size. The direction the wind blows relative to the land has a number of important implications. There are names for the wind directions relative to the shore. Wind blowing directly from the water to the land is called onshore. Wind blowing from land to the water is called offshore. Wind blowing in parallel with the shore is called cross-shore. Wind blowing somewhere between onshore and cross-shore is called cross-onshore. Wind blowing somewhere between offshore and cross-shore is called cross-offshore. Generally, onshore winds are clean as the wind has a clear path over the ocean. And generally, offshore winds have passed numerous obstacles and are very gusty. But these are generalizations, and you must always consider the wind obstacles in a given wind direction. Let's look at a few examples. Here, the wind is cross-onshore. This onshore wind approaches over open ocean and is clean. If the wind was to turn offshore, it would become gusty, of course. This is fairly typical, but not always true. At this next spot, a cross-onshore wind approaches from the mainland. This would be extremely gusty. But if the wind were to approach from the west, it would pass over the open ocean and a smooth aerodynamic pebble bank. In this case, a directly offshore wind would be quite clean. As well as wind quality, wind direction relative to the coast affects your mobility. Many beginners can struggle to edge upwind in marginal conditions. Therefore, with offshore wind, there is an increased risk of riding away from safety if you don't have a rescue boat or shallow water to walk in. Equally, if your kite goes down, you will typically drift downwind away from safety and your starting point. With onshore winds, however, it is generally much easier to return to your starting point. Even if you end up a little downwind, you should be able to walk back to your starting point in the shallows. You should also consider any local hazards and your downwind drift direction. Here, for example, there is a partially submerged shipwreck and an army base downwind. So you need to avoid riding too far downwind, and avoid riding too far out so that you could never drift into these hazards. In some situations, directly onshore wind can pose some safety and mobility issues. If the water is deep and the wind is pushing towards shore and the waves are pushing towards shore, then a beginner will really struggle to body drag upwind and get clear of the beach and the break. As a beginner, you should only try to ride if you can get clear of the shore. Also, a directly onshore wind may push you towards hazards quickly if the beach is narrow. Now, we will look at some basic weather principles all kitesurfers should know. A common weather effect that will impact your kiting is the sea breeze and its opposite, the land breeze. A sea breeze occurs when sunlight warms the land so that it becomes much warmer than the ocean. This can happen easily on a summer day. The surface of the land can heat up several degrees in an hour, whereas the deep ocean takes months to heat up this much. The air over the land is then warmed compared to the air over the ocean. Warmer air expands, becoming less dense and starts to rise. The air over the water is now cooler and denser, so pushes under the warm air. This starts a cycle of wind known as a sea breeze. The sea breeze usually creates predictable wind, and it is generally a clean source of wind. You will need to account for sea breezes yourself, as they are often not covered in wind predictions. Typically the wind would peak in the late afternoon and then drop off in the evening. If you know this is going to happen, this can help you choose when to kite and what size of kite to use. A sea breeze is common at many locations in summer. A land breeze is the opposite effect. This happens when the land is cooler than the ocean. This can easily happen in winter. The deep ocean takes months to cool down, so retains its heat well into winter. The colder land air is denser and pushes under the warmer ocean air, creating a wind cycle like before. Land breezes are often problematic for kite sports. At this location, in winter for example, it's common to find the wind is offshore at opposite beaches. This is due to the land breeze effect. Ideally, we want wind speed to be consistent, or to change slowly enough that you can manage it. If wind picks up too quickly, you can become so overpowered that you won't be able to land your kite, and then eventually flagging out the kite won't work either. You'll still get dragged with the kite flagged out. If the wind drops too quickly, you will end up with the kite stuck in the water. If wind direction changes too much, you'll probably get blown away from your launch area. The first way to find out if the wind will be consistent is to look at the wind prediction, although bear in mind these are not always accurate. Ideally, you want a wind prediction that doesn't change much over the course of a few hours and over the course of your session. The gust number should be fairly close to the wind speed number, and there shouldn't be any precipitation shown. If there are big changes in the base wind, or big gust numbers way above the base wind, or if there's heavy rain shown, then you can expect the conditions to be changeable. The less experienced you are, the less able you are to handle any changes in the wind. When you first start kiting, it can be addictive and you want to get out every possible day, but if the conditions are not safe for you, it's best to leave it and live to kite another day. Another way to predict changing wind is to look at weather and cloud signs. Here's a brief introduction to reading the weather. First of all, lumpy clouds are called cumulus and stretched out clouds stratus. Clouds that are a little higher in the mid-level of the troposphere are prefixed alto. Clouds on the top level of the troposphere are prefixed cirro. There are many other types of cloud, of course, but we're keeping it simple for now. One clear sign of changeable wind is a cloud that grows across these layers. Small cumulus clouds can grow and spread upwards. If they develop across the entire troposphere, these cumulus clouds are then called cumulonimbus. The more vertical growth, the more dangerous the wind changes will be. This is because vertical cloud growth requires strong updrafts of warmer, moister air, and then in turn this produces downdrafts of chilled air, which may be heavy with rain or hail that pull the air down rapidly. These downdrafts can easily reach 50 knots in a tall cloud. When this chilled dense air reaches the surface, it spreads out in both directions, pushing air forwards from the cloud, creating a gust front, and also pushing back from the cloud. This gust front can be deadly to a kiter and can extend well ahead of the cloud and its rain. The taller the cloud and the heavier the rain, the more violent you should expect the gust front to be. So watch out for tall clouds and heavy rain belts dropping from them, and don't wait for them to reach you. The wind will change rapidly as they pass you. Smaller cumulus clouds may change the wind speed, but not to the same extent. Another sign that the wind could change abruptly is a horizontal line of cloud or weather approaching your location. When you see a horizontal line, this is often the border between two different air masses known as a front. For example, a warm front is where warmer air pushes into and over the top of colder, denser air. A cold front is where colder, denser air pushes into and under a warmer air mass. Fronts always bring a change in the wind. This is because the two different air masses have different properties. They can have different wind speeds and different wind directions. Therefore, you can expect the wind before a front to be different from the wind after a front. Furthermore, the front itself can be especially turbulent. There is often heavy rain there, with rapid downdrafts and gust fronts as we saw before. And the border between two different air masses can have significant wind shear. That's where air moving in different directions creates vortexes that can make the wind be even more unpredictable.
Here you can see that there is a very visible front approaching. It is best to be off of the water well before this reaches you, especially bearing in mind that cold gust fronts can shoot far ahead of the clouds. If you leave it too late, you might not be able to land your kite and your safeties might become ineffective. Also bear in mind that not all fronts are as obvious as the one I've shown you here. Sometimes a front can be shown by little more than a line of mist or a line of white water and ripples on the surface. I have once seen a small line of mist approaching with some white water underneath it, and then there was suddenly a change from 18 knots to 56 knots within the space of a few minutes. Fronts can also be seen on wind predictions and also on weather radar if you're lucky enough to have one in your area. Thank you very much for watching. I hope this helps you kite more often and more safely.